In one of the most serious and widespread conflicts in the world in West Asia, Israel, America and its allies on one side, and Iran and the resistance groups in the countries of the region which so-called axis of resistance on the other side. The planes made by the United States have a special role in these conflicts, considering that the upper hand of Israel and the United States in facing Iran and its allies is the well-equipped and advanced 4.5 Air Force such as F-15, F-16, F-18, and more challenging than that, the fifth-generation multi-role fighters, including F-35 and F-22, which are used for the forces' defense of countries like Russia, China, and Iran is considered a serious challenge. In order to deal with stealthy aircraft, which are a phenomenon of air battles in the past decades, many different defense tactics have been developed by competing countries. Less than 2 decades after the start of the Cold War in the 20th century, the development of telecommunication industries made it possible to build high-precision radars. These radars used waves with a shorter wavelength, which means a higher frequency, which had the ability to detect smaller objects with higher accuracy. Especially for fighter planes and missiles, such radars were more suitable so that they could be assigned the job of fire control. The rapid development of air defense systems and radars in the Soviet Union is an example in this regard. On the other hand, the Americans were also looking for a way to hide their planes from radars. The way radar waves return when hitting objects depends to a large extent on the ratio of the radar wavelength to the dimensions of the object. As a result, in general, there are 3 areas or 3 modes of behavior that are represented in this figure. The very high effectiveness of radar or stealth birds against radars with centimeter or decimeter wavelengths is due to the fact that these wavelengths are about 1/10 to 1/100th of the dimensions of the fighter and its key components. Approaches to discover stealthy aircraft. Understanding this phenomenon was the starting point of the radar countermeasures against stealthy birds in the 1990s. The brilliant performance of the F-117A fighter bomber in the Persian Gulf War made countries such as Russia and China struggle. As a result, understanding the aforementioned design philosophy, these countries started returning to high wavelength, lower frequency radars. Improvement of previous radars in VHF and UHF bands using digital processing technologies was the first and fast step in this field. But it didn't take long for several new radars with low frequency and maximum use of new technologies such as solid-state transmitters and digital processing and the ability to track the source of electronic warfare as well as much better accuracy and durability than the previous generation radars in the low-frequency band was developed especially in Russia. Besides that, 2 other methods were also used to improve the ability to detect hidden targets. First, the use of multiple radar receivers in different places, and second, the use of passive radars. As mentioned, the solution of stealth aircraft is the controlled deflection of radar reflections in directions other than the side of the transmitter of the waves towards the aircraft. It should be noted that the usual method is to combine the transmitter and receiver of radar waves in one antenna, but according to the above solution on the side of the attacking force, the defenders thought of using several radar receivers in different places with the right arrangement and distance from the radar transmitter. In this way, the probability of receiving waves whose side is deviated to not reach the transmitter was increased by other receivers. In general, this method of using multi-position receivers is called multistatic. In the field of passive radars, it should be said that these radars do not emit their own waves, and for this reason, passive radars work similar to bistatic and multistatic or multi-positional systems. But passive radars use the waves in the sky that are sent from different transmitters, even with commercial use such as radio and television, to detect targets. Another advantage of passive radars is low production cost and operating cost due to the absence of transmitters and moving mechanical components. Of course, these types of radars require high processing power due to the diverse nature of the received waves, and at least 6 stages of processing the received data must be done in order to complete the task of tracking the target. Also, because passive radars do not emit waves, They are not detected by the enemy's systems, and as a result, remain immune from enemy attacks in order to suppress air defenses. Fewer components needed to set up the system also helps to better protect and hide these types of radars. In this way, these radars can be deployed in areas close to the enemy. Apart from the approach of changing the design of aircrafts, especially airplanes, to reduce radar reflection, the use of materials and colors that absorb radar waves that reduce the energy of incident waves and reduce the possibility of detection and the quality of tracking the aircraft is another solution that is used, although when compared with the main solution, i.e. the shape of the design, it is less efficient. For this problem, radar designers tried to use suitable output power and antennas with optimal performance. It should be noted that stealth aircraft such as F-22 and F-35 have the lowest radar cross-section from the front and have more radar cross-section or RCS from other angles. The reason for this was the focus on optimizing the RCS of these planes to face enemy fighters and interceptors. As a result, when faced with radars from different sides, especially OTH radars that look at these birds from above, they have a higher cross-section. In addition, in the case of radar waves with long wavelengths or in the resonance range, these targets practically do not have radar concealment and are easily discovered, although with a spatial error proportional to the radar wavelength. By reviewing the systems designed especially in China and Russia, it is clear that the network performance of the systems against the attacker's targets is the main approach that makes the defense force superior against the hidden targets of the attacker. According to Western experts, the main working model of the air defense system of these countries is to discover the general position of the target with low-band radars and then focus with other ground and air-based radars and medium-frequency bands to limit the possible space of the target's presence as much as possible and then guide the interceptor fighters and missiles. The defenses have such a small range that they can intercept and destroy the target with automatic radar. For further explanation, it should be said that the updated examples of air defense radars have moved towards combined operation in different frequency bands and high spatial error in VHF band radars with S and L bands, and then focusing the X band radar on a small range in a coordinated, neutral operation. The Russian Nebo-M system is a clear example of this approach, which simultaneously uses 3 radars that are deployed at certain distances from each other in a triangle. The accuracy of medium-band radars such as L in modern examples has increased so much that it can determine the position of targets such as cruise missiles with much better spatial accuracy than previous generations and provide air defense firepower. But in order to achieve maximum accuracy, the X-band radar is also used to accurately search and focus on the range discovered by lower-band radars. This approach has been followed in Iran's air defense by networking different radars from low bands such as HF/VHF/UHF to S/L bands and finally high-frequency band radars. Both external radars and domestic radars share information in a network and search simultaneously and focus on targets in each area. What has happened in Iran's air defense in the past decade? Since the separation of the Iranian Air Defense Force from the Air Force of this country, in addition to increasing the qualitative and quantitative trend of equipping with advanced systems that can be purchased from abroad, a more targeted development trend was followed in domestic products. Foreign models purchased a decade ago, specially designed to work in forested environment, with AESA technologies and passive jamming source tracking capabilities, including Nebo radars in the VHF band, Costa in the UHF band, and Gamma in the band L has been. These radars are actually the most prominent examples among the products designed in Russia with advanced technologies to deal with covert targets after the Cold War era and to observe the performance of these birds in the Persian Gulf War. Also, the Belarus-made Vostoky radar has been observed as one of the most prominent radars against hidden targets in the Air Force of our country. According to calculations provided by Western sources, this radar is capable of detecting targets with a radar cross-section of 0.01 square meters for more than 140 kilometers. In the following, the specialists of this country made Iranian samples similar to foreign ones to increase the quantity of radars and expand in different places, as well as samples without foreign counterparts and indigenous designs, both of which are largely unknown to the enemy, especially examples with indigenous designs. Various bistatic and multistatic radars were built in the country, and along with them, some indigenous passive radars were developed in the Army and the IRGC, some of which have a range of more than 200 kilometers. The new and advanced radar includes the new example of Kadir radar with a range of 1,100 kilometers, which is very similar to the layout pattern of the Russian resonance radar, the Persian Gulf radar with OTH or over-the-horizon capability with a range of 800 kilometers, and the phased array surveillance radar in 2020. The country's air defense system was added, and all these radars have network functions. But another indigenous solution specially developed in Iran to detect hidden radar targets is optical detection systems. These systems are usually deployed in a complementary role alongside missile and artillery air defense systems, but the construction of models with a much greater range than before in recent years has made them a desirable support point for the country's air defense network. In the past, thermal sensors were specifically looking for heat sources such as aircraft engines, but with the development of imaging sensors, optical systems can detect even lower temperature differences with the environment and discover different targets in harsh weather conditions and at long ranges. In addition, long-range visible optical sensors have also been developed in the country, which, under appropriate conditions, provide the possibility of visual identification. As an example, we can mention the two systems TICS-1 and TICS-2, which are manufactured by the Ministry of Defense of Iran and are used in the field of air defense, and of course, they are presented in export samples with these names. The cooling sensors of these systems
now the US has poured hundreds of billions into studying stealth and developing stealthy aircraft. Let's review the progress of stealth technology in the modern world today. In today's list, we present you guys the top 6 best stealth aircraft in the world today. Do not go anywhere, stay tuned.
Temperature of -40 degrees to +60 degrees Celsius. This system can also be installed and used on fighter planes. Considering that today advanced 4th generation and 5th generation fighters in the world use electro-optical detectors with a range of more than 70 kilometers, TICS-2 thermal detectors can significantly improve the ability of Iranian fighters in the field of electro-optical detection and tracking. It is obvious that gaining the title of the best side between stealth attackers and defense defenders is frequently changing hands due to the continuous growth of technologies every day, along with obtaining information about the other side's technical abilities and tactical approaches. One of the leading factors on the side of the attackers is the stationary weapons, which have grown in a size suitable for fighters, especially in the last 20 years, and new models that can be carried inside the vestibule of stealthy aircraft are also expanding. However, due to the dimensional limitation of the vestibules, the range of pre-carried samples in them is significantly less than the samples fired from large bombers or 4th-generation fighters. A general point that should be mentioned about long-range air-launched weapons is that if communication is established between the weapon and the carrier aircraft after launch, for example, to send coordinates or receive data from the weapon, this communication can be easily carried out by ESM systems up to a radius of more than 200 kilometers. It is discovered and the existence of stealth planes is revealed with good spatial and angular accuracy regardless of whether it is in the sight of other sensors or not, and the risk of interception and destruction by defense systems increases. Therefore, in the following, it is assumed that no communication will be established between the aircraft of the attacking flight group and the aircraft and the abandoned weapons. The main approach to continue the discussion is, of course, about the possibility of detecting a stealthy bird before launching its weapon. Stationary weapons can generally be divided into motorized and non-motorized categories. In the first category, the presence of the engine allows the firing plane, assuming no need for fuel tankers, which causes easy detection of the enemy's attacking bird, to be able to approach the firing point at a low altitude and avoid the sight of defense radars as much as possible. To solve this problem, i.e. flying at low altitude, over-the-horizon radars or OTH have been developed, and there are prominent Russian, Chinese, and Iranian examples in this field. In Iran, this category of radars includes SAPER with a final range of 3,000 kilometers to samples such as the Persian Gulf with a final range of 800 kilometers, due to the radiation of these radar waves from above to the target. Lowering the flying height of the attacking bird will not help to hide it from the sight of these radars. These radars even have the ability to detect the target before it takes off from the runway and only by its movement on the ground. Regarding motorized long-range weapons, it should be noted that, firstly, due to the limitations of the corridor of stealth fighters, the range of this type of long-range weapons is currently less than the range of missiles of long-range air defense systems such as S-400 and Bavar 373. However, in case of success in the firing of stationary weapons by the enemy fighter, the weapons with engines can be detected by appropriate defense systems such as thermal imaging sensors due to the thermal effects of the engine and handed over to explosives for conflict. But in the second category and long-standing weapons without engines, since the energy required for the flight of this weapon is basically obtained with the initial speed and height received from the planes that release it, the enemy fighter is forced to reach the speed of the sound limit, which increases the thermal effects. And also to take a more than average height, about 8 kilometers above, in order to be able to reach the greatest possible range of his weapon without a motor or so-called airborne or glider. The most famous example of these weapons are the American GBU-39 or SDB-1 bombs, which, according to the available information, reach a range of 110 kilometers when launched from a height of nearly 10 kilometers. At this height and according to the information mentioned about low-frequency band radars and resonance range, a stealth aircraft like F-22 can be detected and tracked. Especially if it is decided to implement the ascension phase of these fighters as soon as possible, a large part of the lower surface of their body will be exposed to the radar waves of the defending side and it will increase the possibility of their discovery. In this context, it is also necessary to mention that the F-35 aircraft, despite having some newer and more advanced equipment and subsystems compared to the F-22, was inferior to it in the field of radar reflection from the beginning. This decision of the manufacturing company and in fact the U.S. Ministry of Defense or the Pentagon has been based on the adoption of a wide export approach for this aircraft, so that the F-22 fighter as an exclusive product of the U.S. Air Force in the field of radar concealment is at a higher level than the fighter that is available to other countries. Many will be placed. As a result, the problems of the defense network to detect and track the F-35 are less. Finally, to summarize this section, it should be said that the progress of air defense systems in the field of conflict and destruction has reached the ability to deal with small targets such as artillery rockets and air-launched ammunition. The Battle of Syria, especially in recent years, when Israel's air-based and long-range attacks have expanded to this country, has well demonstrated the strengths and weaknesses of short-range air defense systems such as Panzer S-1, Tor M1, and Tor M2. Facing these ammunitions and weapons showed throwaway. In summary, it can be said that these systems are very successful in the field of detection, but in the field of conflict, it is not a technical problem, but there is a need to increase the volume of defense systems to deal more effectively, which is the challenge facing these systems. An auxiliary solution to these systems is the use of various decoys to disrupt the weapon's final phase seeker, as well as disruptive systems in global positioning such as GPS, which by diverting the attacker's weapons lead to the enemy's attack becoming less effective. What is Lunenberg lens? One of the most important points about stealth planes is their use of a device to deliberately increase the radar reflection called Lunenberg lens. What is proposed by the manufacturers of these planes is that the purpose of the Lunenberg lens is to be able to identify these birds in non-combat conditions for aviation safety and, of course, to make their radar cross-section unmeasurable in these conditions for the enemies. But this coin has another side. As a second possibility, which may not be definitively evaluated until a real conflict, it can be said that putting forward a concept called the creation of deliberate radar reflection can also be a cover for the lack of high efficiency of the stealthy bird against some radars. Especially in the case of the F-35 fighter, the approach of extensive export is one of the main axes of its development project, and buyers have invested and waited for years in the hope of receiving a fighter with a high level of stealth. Also, bringing up Lunenberg's lens can easily marginalize the reports of air defense systems in countries like Iran in the field of discovering F-35 VA F-22 fighters in the media space, because the users of the fighter easily mention the installation of this device on the plane without anyone with photos, and the film asks them for proof. An example of these reports, which was pushed to the sidelines by stating that it was equipped with a Lunenberg lens, goes back to the story of the F-35 flight in Germany and its detection by an airport radar in recent years. But what could strengthen the second possibility have been unofficial reports of Israeli F-35s being detected by Syrian-based radars at the time of the airstrike. It is unacceptable that the Air Force of this regime would fly this fighter with the Lunenberg lens in a real combat operation and put it in danger, when it can use the F-15I and F-16I fighters if it does not need a stealth fighter. Use it as before. Creating real combat conditions for F-35 pilots to practice and gain experience is not a good excuse to answer this doubt. In any case, at the end of this report, it should be mentioned again that in the world of military technology, no elixir and finishing solution for attacking the enemy or defending against the attacker has been created, and both sides of the conflict are constantly improving the quality and quantity of their equipment for increasing the probability of excellence and expanding the level of excellence are possible. Iran's armed forces are no exception to this rule, and for this reason, they are constantly moving in this direction by using knowledge-based power in defense industries and other scientific and research centers to ensure stable and deterrent security.